Inside every CPU, beneath billions of transistors, there is a hidden language. A language that never appears in textbooks. A language that programmers never write. A language spoken only by the hardware itself. This language is called microcode, and it quietly shapes everything your computer does. When we write code, we think in logic. When we write assembly, we think in instructions. But the CPU does not think in instructions. It cannot understand, add these numbers, or jump to this address. To the CPU, these commands are still too large, too abstract, too human. The CPU needs smaller steps, precise steps, electrical steps. Microcode provides those steps. Is the translation layer between human intent and machine reality. Microcode is a collection of tiny operations. They are called micro-operations or micro-ops. Machine code says, do an add. Microcode breaks that into a sequence. Move data from the register file. Activate the arithmetic unit. Perform the addition. Store the result. Update the flags. Each of these is a micro-op. Together, they form the real work inside the CPU. Microcode is not fast, is not glamorous, but it is essential. Imagine the CPU as an orchestra. The ALU is the brass section. The registers are the strings. The control unit is the percussion. Machine code is the sheet music, but microcode is the conductor. It decides which parts of the hardware activate. It decides when they activate. It decides how they work together. Without microcode, the CPU would be noise. With microcode, it becomes music. In the early days of computing, CPUs were built with hardwired logic. Every instruction was physically wired into the chip. If you wanted a new instruction, you needed a new chip. This made CPUs fast but rigid. They were machines carved in stone. Then microcode arrived. It allowed designers to define instructions in software-like sequences. It made CPUs flexible, programmable, upgradable. This shift changed the entire industry. It allowed complex instruction sets. It allowed compatibility across generations. It allowed innovation without redesigning the entire chip. Microcode became the silent foundation of modern computing. Microcode lives in different places depending on the CPU. Some microcode is stored in ROM. Some is stored in flash memory. Some is loaded by the operating system during boot. This layered design allows manufacturers to fix problems after the CPU is shipped. It also allows them to add new behaviors, or disable old ones, or optimize performance. Microcode is not just a translator, it is a control system. Here is the surprising part. Modern CPUs can receive microcode updates. If there is a bug in the silicon, or a security flaw, or a timing issue, manufacturers can fix it with a microcode patch. No new hardware, no recall, just a new set of micro-instructions. It is like updating the brain of a machine that already exists. This ability saved the industry during major security events. It allowed CPUs to evolve long after they left the factory. Today's CPUs break complex instructions into micro-ops. Even simple instructions often become multiple micro-ops. This allows the CPU to run instructions out of order, to speculate, to pipeline, to run many operations in parallel. Microcode is the blueprint that makes these optimizations possible. It defines how instructions flow through the pipeline. It defines how the CPU handles hazards. It defines how the CPU recovers from mispredictions. Microcode is the choreography behind modern performance. Not everything uses microcode. Some instructions are still hardwired. Hardwired logic is faster. Microcode is more flexible. Modern CPUs use a hybrid approach. Simple instructions are hardwired. Complex instructions use microcode. This balance gives us the best of both worlds. Speed when we need it. Flexibility when we must have it. Microcode is powerful. It can change how the CPU behaves at its deepest level. This makes it a security boundary, a weak point, a target. A flaw in microcode can compromise the entire system. This is why microcode is encrypted. This is why it is signed. This is why it is rarely documented. Microcode is the CPU's most closely guarded secret. Every app you open, every game you play, every line of code you write, all of it passes through this hidden layer. Microcode is the invisible translator between human logic and machine physics. It is the silent conductor that brings your code to life. It is the secret language inside the CPU. So the next time your CPU executes billions of instructions per second, remember this. Behind every instruction is a whisper, a sequence of micro-operations. a hidden choreography, a secret language. This is Microcode, the silent heart of modern computing. Thanks for watching, and I'll see you in the next chapter of this digital adventure.